Hi guys, welcome to Pencil College. In this video, we'll be dealing with some challenging examples from parallel and non-parallel lines. Okay, so if you have forgotten what it means for a line to be parallel or non-parallel, please review the previous video. Okay, because since the examples are more challenging, your basic concepts must be strong, okay, before you can understand these examples. So example 3a, the diagram shows a trapezium in which AD and BC are parallel to the line 2y plus x equals to 0. Okay, so at this point in time, since we are told that CD is parallel to the line 2y minus x equals to 0, okay, what I will do is to rewrite this line to make it look more, in a form that is slightly more familiar to us. So 2y minus x equals to 0 can be rearranged to become 2y equals to x, and dividing both sides by 2, I'll get y equals to half x. Okay, so recall that the equation of any straight line is always in the form y equals mx plus c, and therefore our m in this case is just half. Okay, so since CD is parallel to the line, okay, to this line now, okay, let's call this line L1. So since CD is parallel to L1, we can say that the gradient of CD is equals to half. Okay, recall that if two lines are parallel, then their gradients is the same, and half is simply the gradient of line L1 over here. Next, AB is parallel to the x-axis. Okay, so if you have forgotten, the x-axis is a very special line because the x-axis is actually denoted, or so what I'm saying here is that the x-axis has the equation y equals to 0. Okay, so therefore the gradient of AB is 0. Okay, moving on, the question says that the coordinate of A is 6, 2 over here, indicated over here, and the length of AB is 3 units. Write down the coordinates of B. Okay, now let us find the coordinates of B. So since line AB over here is parallel to the x-axis, we can say that the y coordinate of B is the same of, or rather is the same as the y coordinate of A, because this distance is the same, which is just 2 units. Okay, therefore we just need to find the x coordinate of B. So to find the x coordinate of B, okay, let us make use of distance AB. So distance AB, okay, is actually a horizontal line. So let me probably use a different color to make it more obvious. So distance AB is over here, and the length of this horizontal line is simply the x coordinate of A minus the x coordinate of B. Okay, and we're also given that AB is 3. Okay, so the x coordinate of A is 6. Let us find the x coordinate of B by solving this, and by shifting this over. Okay, so concurrently shifting the 3 over and xb over to the right. Okay, xb is just 3. Therefore, the coordinates of B is 3, 2. Next, let us go ahead and find the coordinates of D. Okay, in order to do that, we must first find the gradient of line AD. Okay, so let me use a different color to indicate this. So okay, let us also take note that in this portion of the question, it is stated that AD and BC are parallel to the line 2y plus x equals to 0. So where exactly is line AD? So line AD is over here. So as you can see it with my blue pen over here, and these two lines are parallel. Okay, so let us work on the given equation. So from the equation, let me continue over here. 2y plus x equals to 0. Okay, I'm using this equation over here. Okay, let me rearrange to get 2y equals to negative x, and then y equals to negative half x by dividing throughout by 2. So I realize that the gradient of this line AD is actually just negative half. Okay, so the gradient of line AD is negative half. Let me write it down over here. So let me just split the screen by 2. So gradient of AD is negative half. Okay, so by supping a point, which is point A, let me use by supping point A and the gradient into our general equation for any straight line, so sub x equals to 6, y equals to 2, and m equals to negative half into y equals to mx plus c, we'll have 2 equals to mx plus c. Solving this, we will arrive at c equals to 5. Therefore, the equation of line AD is simply y equals to negative half x plus 5. Okay, and from here I can identify my y-intercept to be positive 5. Okay, and take note that since D is the y-intercept, the coordinates of D is simply 0, 5. Okay, because the coordinates of the x-coordinate of any point along the y-axis is always 0. Okay, so therefore our answer for D is just 0, 5, and previously our answer for B is just 3, 2. Okay, that's all for example 3a. I hope it wasn't too tough for you. Okay, and before we move on to example 3b, I just want to highlight that previously we found that the gradient of CD is half, okay, from this given portion of the question. Okay, so this portion of the question over here, previously highlighted in yellow. Okay, from here we found that gradient of CD equals to half. Okay, we'll be making use of this fact in example 3b. Now in example 3b, we are asked to find the equations of line BC and CD. Okay, so let me first draw, or rather highlight or indicate where is line BC. So line BC is over here, and take note that line BC is parallel to line AD. Therefore, we can say that the gradient of BC is equals to the gradient of AD, which in the earlier case we found to be negative half. Okay, and also a point on the line BC is point B, which was previously found to be 3, 2. So if I were to sub, okay, so B is 3, 2. If I were to sub x equals to 3, y equals to 2, and m equals to negative half into y equals mx plus c, then I'll have y, which is 2, equals to m, which is negative half, x plus c, and c is just 3.5. Okay, therefore, the equation of line BC is simply, is simply y equals to m x plus 3.5. Okay, and if you want, you can multiply 2 throughout this equation to get 2y equals to negative x plus 7, and rearranging, we will have 2y plus x minus 7 equals to 0. Okay, and that's the equation of line BC. Now let us move on to look at line CD. Okay, so probably for this I'll use a different color. So line CD is over here. And recall that in example 3b, we found our point we found our gradient CD to be positive half. Okay, and previously we also found point D to be 0, 5. Okay, so I have gradient of CD to be half and point D to be 0, 5. Okay, if you have forgotten how we got our gradient CD, we got it from this equation over here, since CD is parallel to this line. Okay, so if you have forgotten, please rewind the video to the first portion of example 3a. Okay, so if I were to sub x equals to 0, y equals to 5, and m equals to half into y equals mx plus c, I will have y, okay, y equals to m x plus c. Okay, and c is just 5. Therefore, the equation of line CD is just y equals to half x plus 5. Okay, and if I were to multiply by 2 throughout, I'll get 2y equals to x plus 10. And shifting everything to the left hand side, I'll have 2y minus x minus 10 equals to 0. Okay, and there we have it. This is the equation of line CD. Okay, and finally, in example 3c, we are asked to find the coordinates of C. And before we do that, I just want to point out that C is the intersection of lines BC and line CD. Therefore, to find point C, which is over here, okay, all we need to do is to solve line BC and CD simultaneously. So let me just write down lines BC, which we have gotten in example 3b, okay, as well as line CD. Okay, so it's easier to solve. So I to say we'll be solving equation 1 and equation 2 simultaneously. So solve simultaneously. Okay, so equating equation 1 to equation 2, I will have negative half x plus 3 half equals to half x plus 5. Shifting negative half x to the right and 5 to the left, I will have x equals to negative 1.5, and therefore the x coordinate of C is just negative 1.5. Okay, then sub x equals to negative 1.5 into equation number 1, I will get y equals to negative half times negative 1.5 plus 3.5, which will just give me 4 1/4. Therefore, the coordinates of C is just negative 1/2 and 4 1/4. Okay, and there we have it, the coordinates of C. Okay, so I hope this example is not too challenging for you. Okay, if you couldn't understand some parts of it, please feel free to rewind and review this video. Okay, so just to summarize, we've come to the end of this section on parallel and non-parallel lines. Okay, so I'll just pause here for a while for you just to absorb the diagram, which I've elaborated in the earlier part of this chapter. And finally, before we end this video, just want to leave you with some practice questions. Feel free to pause the video here and take it down. And finally, thank you for watching this video. I hope you have enjoyed it. And for more videos, please log on to pencilcollege.com. I'll see ya.